let's go over them. So for the first one, how do we start with the first one? We start finding the z. This angle is 90. We can find the z by using the Pythagorean theorem. Z square or z square is 2 square plus 4 square. That's 4 plus 16, 20. So z is the square root of 20, which is 4 by 5, and that simplifies to 2 square root of 5. That's z. For y, we can look in the upper triangle here. This is 4 and 4. So y square equals 4 square plus 4 square. 16, 16, 32. So y is the square root of 32, which is 16 by 2. And that gives us 4 square root of 2. Now that will leave an x, which is the square root of 4 square plus 4 square plus 2 square. 32 plus 4, 36, which is 6. So then x plus y plus z. X is 6, y is 4 square root of 2, and 2 square root of 5. Is that okay, guys? How many pairs of parallel edges does a cube have? The best thing to do is to draw a cube like this, label it A, B, C, D, E, F, G, H. So how many pairs are parallel? How many you guys got? So AB parallel to what? To DC, to EF, to HG, right? We have BC parallel to AD, EH, FG. We have BF parallel to GC, AE, DH. What else we have? Any other parallel lines? It says how many pairs of parallel edges? Any more? So how many? Any more can we find? So I counted the ones are parallel to AB in the same direction as AB. I found DC, EG, and EF, right? So how do we get them out? So AB goes with DC, right? AB goes with EF, AB goes with DG. That's 3 of them so far. So 1, 2, 3. Then DC goes with EF. That's another one, 4. DC with HG. That's 5. And EF is 1, 6. So I have 6 possibilities for the first one. And it's going to be the same for the next one and the last one. So the total is 18. Total 18. How about the last one? Did you guys get a chance to try it, or you need more time? Can we go over the next one? So they said, usually when they give ratios and they don't give you numbers, you can pick any numbers you like and you will get always the same answer. So say the side length of the cube is 2 and this is 1 1. Don't take the side 1 because you got decimals or fractions 1 1 like that. Everything else is 2's. So they said the area of that slice, as you can see, what is that going to be? Or cross section. We can find the area of that cross section. So R equals the area of the cross section. Well, if this is 1 and 2 in this triangle here, we can find BI by the Pythagorean theorem. Is the square root of 1 square plus 2 square. Square root of 5. So this is square root of 5. Okay, same thing here. 1, 2. This is a 90-degree triangle. Square root of 5. Okay, so is that a square? Is that piece a square? It looks like a square, right? To us, it's a square. So the area of that one is the square root of 5 times the square root of 5. Is that okay? Now, what's the area of one of the faces? Well, the face is 2 by 2 face, so the area is 2 by 2. So they want us to find R square, right? R square means you're going to square all of this. That would give 5 times 5 over 4 times 4. You have to square each one of them. Is that, we have to be careful in the slicing or that cross section. I did get square root of 5 and all of them are square root of 5. But guess what? That doesn't mean that's a square. I was wrong when I said it's a square. You know why? What could that be? You can only prove that's a square if you can find one angle to be a right angle. Right? To be a right angle. So this figure so far, I can't prove this is 90 or not. I don't know. So this is a rhombus now, right? It's a rhombus. So that figure is a rhombus. So what are we doing is this figure here on the top, this cross section is rhombus. Then how are we going to find that rhombus? Well, what's the area of the rhombus? Area of any rhombus, if you look back at the areas, it's 1/2 diagonal 1 times diagonal 2. Diagonal 1 times diagonal 2. And watch how I'm going to do this. You can connect IJ, that's a diagonal. But guess what? IJ and AC are the same. IJ, and you agree with me, right? So to find IJ is the same as AC. So it's 1/2 AIJ times the other diagonal. Other diagonal is BG. BG, that's the other diagonal, times BG. So what does that give us? It's not going to be square root of 5. Equals 1/2 . ij is the same as AC. And AC, how do you find AC? In this triangle down here by the Pythagorean theorem is AC, let me write it here. AC is the square root of 2 squared plus 2 squared. 4 plus 4, 8. So it's the square root of 8. And BG is the longest diagonal. We give you a formula earlier. Is the first side square, next side, next side. 4, 4, 4, that's a 12. Square root of 12. Now we're going to square each one of them. That becomes 1/4. That's an 8. That's a 12. If you square them, 4 and 4. So let's see what we get. By 4, 1, by 4, 2. 2 times 12. By 2, 1, by 2, 2. By 4, 1, by 4, 3. The answer is 3/2. Any questions so far? Everyone okay with this? Everyone copied the notes? So I'm preparing the next one. Three dice with faces numbered 1 through 6 are stacked as shown. So they numbered 1 through 6. We stack them this way. 7 of the 18 faces are visible to us, leaving 11 faces hidden, back, bottom, and in between. The total number of dots, so we need to find the total number of dots not visible in this view is what? Okay, everyone done with this? So let's see how we find the non-visible ones. For the top one, remember the numbers go from 1 through 6, like the dots. So what is the total here? 1 plus 2 plus 3 plus 4 plus 5 plus 6. The easiest way to find per these, that's a 7, 7, 7. 3 sevens. 21 dots on each figure. What do you think? Is that true? 21 dots. So how many dots you missing on the first one? There's a 5. I see 5 of them, or 6. 6. So how many missing there? 15 on the first one. Here I see 3, 3, 6, 7, 8, 9, 10. 10, this means 11 missing. Here I see 1, 2, 3, 4, 5, 6. That means another 15 missing. So 15, 15, that's 30, 41. Anyone got 41 as an answer?
I did.
Okay, we have one got 41. Okay, the next one I have in mind, we have a cube with side 2. We glued another cube on the top of this, so that's a cube of side 2. We glued another cube with side 1, totally like on the top of this one. So it says a cube of edge length 2. Suppose that we glue a cube of edge 1 on the top of the big cube, so that one of its faces rests entirely on the top face of the larger cube. They asking to find the percent increase in the surface area. Surface area, we mean the sides, top and bottom, from the original cube to the new solid formed is closest to what? So think about this. Everyone give it a thought. So how do we do this? Who's gonna tell me? We need to find the percent increase in the surface area. So what was the original surface area?
24.
It's one side, which is 2 by 2, 4 times 6. Yeah, good job, 24. That was the one before we glued that thing on the top. The new surface area, well, it's the way you do it. I always do it this way. I take the surface area of each one, add them together. So the next one is 1 times 1 times 6. So that's 1 times 6. So that's a total of 24 plus 6, 30 so far. But there's an overlapping here. This piece here down there is counted twice. So we have to remove that. That part is hidden now. 1, 1 twice. So minus 1 times 1 and minus 1 times 1 again. So minus 1, minus 1, minus 2, that's 28. Okay, so that's so far that's the new one. Any more? That looks good. So they want us to find the percent increase or the percent change in general. How do you find the percent change? The percent change, we always we find the final minus the original over the original times 100%. So the final is 28. Original was 24. Original 24 times 100%. This gives us 4 on the top over 24 times 100%. By 4, 1, by 4, 6. So that gives us about 16.67%. So we have next one, we have a cylinder and there is a hollow cylinder inside it. So what we need to find out, find the surface area and the volume. So the cylinder inside is a hollow cylinder. There's nothing in there. It's an empty cylinder with diameter 2. And the bigger one is a cylinder with diameter 6. So what's the surface area and the volume?
Is there a height?
Yes, thank you. Let me give you a height of 8. So to find the volume, first I'm gonna find the volume. Is the volume of the whole thing pi r squared times the height minus, oops, pi r squared times the small the height for the small one. So the radius for this is 3, the height is 8, the radius for the other one is 1, the height is 8. 72 pi minus 8 pi, 60, what is this? 64 pi. For the surface area, watch how we do it. I'm gonna find the surface area of the big one, 2 pi r square, plus the surrounding 2 pi r h minus, I'm gonna remove this circle and the bottom circle, 2 times pi r times 1 square, and then we have to add the inside part of that cylinder. So guys, do you see the inside of the highlighted part? That is part of the surface area. So that's 2 pi r is 1 times the height, 18 pi, 16 times 3, 48 pi, minus 2 pi plus 16 pi. And I'm sure you guys can add this up. 80 pi.